could present about ethical dilemma in balance, cost regulations, and safety in solar photovoltaic or PV project. As a demand, renewable energy continues to increase. Many companies aim to reduce project costs to make a solar energy more affordable and competitive. However, excuse cost cutting can lead to serious safety issues such as poor quality material, unsafe working conditions, and regulated system reliable. This creates effect challenge of a project manager and engineering because they must balance financing efficiency with a responsibility to protect working user and environment. Therefore, it's important to ensure that a safety standards are not compromised with achieving sustainable and cost-effective solar PV development. Now we go to next slide is a engineering technology challenge for cheap materials versus safe design in a solar PV project. Engineers often face ethical dilemma between regulations, project costs, and ensuring system safety. The use of cheap material such as low-quality solar panel or cable can reduce installation costs. However, it may increase the risk of a system failure, short circuit, and fire hazard, while also reducing the system lifespans. On the other hand, safe design uses high-quality material and a better protection system. The cost is high if it provides stability, performance, better durable, and reduce safety risks. In conclusion, cost regulations is important in a solar PV project, but user safety must always be priority to use safety and reliable system. Thank you.
Positive impact of sustainable development associated with pressure with clients to reduce costs. There is 5 positive impacts that I found. The first one is sustainable practices. Companies adopt sustainable practice to save resources. Second one is energy saving. Companies reduce energy usage to lower expenses. Next, higher efficiency. Sustainable methods improve efficiency and productivity. Then, client cost pressure. Clients encourage companies to reduce operating costs. And the last one is waste reduction. Reducing waste helps decrease production costs.
A negative impact arises when we allow the ethical dilemma of cost versus safety to lean too far toward cost reduction. Negative impact is the compromise of human safety. When there is an intense pressure from client to reduce costs, the immediate result is often of the selection of cheap material over a safe design. This isn't just a budget choice, it's a high-risk gamble. Using substandard mounting structure of inferior electrical component lead to real-world consequences like electrical fire, structural collapse, and long-term system failure. Furthermore, this shortcut lead to failure in regulatory compliance by ignoring the standard set by bodies like TMB or SEDA. We aren't just breaking rules, we are creating poor design that undermine the credibility of the entire renewable energy industry. Ultimately, the negative impact is a cycle of waste. The system that was meant to sustainable become a hazardous liability that requires more resources to fix than it ever saved in the first place.
Good day everyone, my name is Wilson, son of Vedaraj Prabhu Johnson, and I am from FTKE BELK program, number matrix B112510205. Today I will present about professional ethics and norm focusing on the real world consequence of poor design. Professional ethics requires engineers to design system responsibly, not just to reduce or increase the cost efficiency, but also to protect long-term social welfare and public safety. Engineering decision can affect communities, the environment, and also the future generation. Poor design occurs when safety considerations are ignored or when cost effectiveness is prioritized over ethical responsibilities. While cheaper solutions may seem beneficial in the same short term, they can cause serious accidents and also long-term social damage. A well-known example is the High Regency Walkway collapse, where an unreviewed design change caused structural failure and loss of lives. This tragedy demonstrates how unethical design decision can impact society far beyond financial loss. In conclusion, ethical engineering means balancing cost, safety, and long-term social impact. Responsibility design protects lives and builds public trust. Thank you.
Compliance with standard, TMB and SEDA. In Malaysia, solar PV project must follow guidelines set by Tenaga Nasional Berhad and Sustainable Energy Development Authority. The first one use of a quality component. Cheapest panel, inverter or cable may be reduced upfront costs, but they often degrade faster, perform inefficiently, increase risk of overheating or failure. The second one was cutting corner in installation. Some contractor may be skip proper grounding, use undersized cable, ignore the safety spacing. They may not show immediately problems, but over time, it can lead to fire hazard or system breakdown. The third one, long-term versus short-term thinking. A low-cost system might look attractive initially, but higher maintenance costs, lower efficiency, shorter lifespan. The ethical dilemma is balancing immediately affordability, long-term sustainability, and safety. Compliance with TMB and SEDA ensure that solar PV systems are safe, reliable, and legally approved. However, in trying to reduce cost, project developers may face ethical dilemmas that can compromise safety, quality, and honesty. A responsible approach requires balancing cost efficiently with a long-term performance, safety, and ethical responsibility.